Hi Dragons, and welcome to Interactive Notebook page 17. I actually want to rename this page. I was surprised at the title when I was re-examining it. I want to call it, if I can find a pretty marker, but I may not, GCF and LCM using prime factorization. GCF and LCM using prime factorization. Fantastic. Now, these strategies may seem complicated. So if they don't come naturally to you, don't worry, I'm not going to test you on them. But I do want you to see them and know that they exist. You'll probably see them again in 7th grade. I can use prime factorization of two numbers to find the GCF or LCM. I can use exponents effectively. So, finding the GCF is like chopping up the number. You are searching for factors. Little device that might help you. It's like a ninja chop. Now we're going to find the GCF between 30 and 45. We know one way to do that would be the factor rainbow. But this time we're going through this step list. We're going to use prime factorization. Let's take a closer look at this. So step 1, list the prime factors of each number. Okay. So I'm going to break it down. I'm going to do 30 is 5 times 6. 5 is prime. 6, we're going to go 2 and 3. So the prime factorization of 30 is 2 times 3 times 5. Now we're going to do 45. Now we might travel down our trees differently, but the prime factorization will be identical. So prime factorization is 3 times 3 times 5. Now I'm not going to put it in exponential form yet, because I'm trying to prove that they have common prime factors. So sometimes it helps to line them up. And here's what I mean. I'm going to do prime factorization of 30 over here, and prime factorization of 45 over here. And 30 is 2 times 3 times 5. And 45 is 3 times 3 times 5. Notice that there is no 2, so 2 can't be a match. They do share 3. They don't have a second 3, but they do share 5. So I just line them up so it's easier for you to find who they share. Now, these were common prime factors. They each had it. Common means basically alike. Prime factors, you get prime factors when you use a factor tree. So they share 3 and 5. Well, when you're finding the GCF using prime factorization, you multiply the common prime factors. So they share 3 and 5. The GCF will be 3 times 5, which equals 15. When I first learned this method, I thought they meant do 3 times 5 times 3 times 5. Because it's like, oh, multiply all the common prime factors. It doesn't work that way. They just want you to list the common one once. Just list it once. So they share 3, they share 5, multiply those two. The greatest common factor, the biggest number that can go into both of these, 30 and 45, is 15. Now let's use a rainbow to test it. So I'm going to find my factors of 30 using the rainbow method. I'm going to check really quick and see if that color shows up for you guys. Okay, fantastic. So I'm going to do 1 and 30, 2 and 15, 3 and 10, 4, 5 and 6, 7, 8, 9. Nope, I think we're good. All right, I'm going to do a rainbow for 45. One and 45. 2 doesn't work. 3 and 15. 4 doesn't work. 5 and 9. 6 doesn't work. 7, 8, we're back at 9. Okay. Now, we can go in and circle who they have alike. They share this common factor. 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 Well, 15 is the largest common factor. Common being they share it. So either method, we got there. But the purpose of this video is to emphasize the first method, using prime factorization to find the GCF, and the steps are listed for you. Now what's cool with prime factorization is you can also find the least common multiple. This one's a little unusual, so let's work it out together. I'm going to walk through the steps with you. List the prime factors for each number. I find the first step very easy. That step doesn't stress me out. We're going to make a factor tree for 12 and for 18. Remember, we can go down the branches differently, but our answers will be the same. So, for 12, it's 2 times 2 times 3. If you're ever unsure, you can just multiply it. 2 times 2 is 4. 4 times 3 is 12. Okay, we got 12. Let's do 18. So that looks like 2 times 3 times 3. Now the steps are different here. We're finding least common multiple. Multiple is getting when you're skip counting. So multiple is skip counting. I've seen some teachers call it like it's a megaphone because it's getting louder and multiplying. The numbers get bigger. We want numbers to get bigger. So with LCM, the numbers are growing because you're skip counting. Now here's the next step. Multiply each factor the greatest number of times it occurs in either number. Multiply each factor the greatest number of times it occurs in each number. So in this number, it's 2 squared times 3. And in this number, it's 2 times 3 squared. Multiply each factor the greatest number of times it occurs. Okay, what is one of the factors? 2 is one of the factors. What is the greater exponent? 2 squared. 3 is one of the factors. Who is the bigger one? 3 squared. So they want us, and there are no other factors. There's no 5 or 7 or any other prime factor here. So you pick the biggest, the greatest power. That factor occurs or happens in, the greatest factor. So the LCM will be 2 squared, because 2 squared trumped 2, times 3 squared, because 3 squared trumped just 3. And that 2 squared is 4, 3 squared is 9. So the smallest multiple that 12 and 18 share, remember you're growing, is 36. We're going to test this using the list method. You could do a table, I'm just going to do a list. So I'm just going to skip count here. 12, 24, 36, 48. I could keep going if I needed to. 60, 72, 84. Now, I'm going to do for 18. We got 18, 36, 54, 72. I'm looking for common multiples. They have a match at 36. They have a match at 72. But we want the smallest one. This one is the smallest one. This is a common multiple, but not the least common multiple. So again, the least common multiple, even using our alternate strategy, is 36. Now your interactive notebooks should be piecing together quite nicely at this point. We have completed a lot of previously blank pages. Things should be looking really nice. Thank you.